working in a project with development mode, working in a project in a kind of feature maintainability mode. Feature maintainability in the sense that kind of enhancement or bug fixing is software is available. Whereas in development, software is not available. Means someone is developing the software from the scratch. So in development mode, a developer need to include many libraries. Where in maintainability code, the developer has the software. So in both cases, a developer needs to know about the either library package or the current software. If we see Python is kind of loosely or it doesn't have any explicit type, function signature, class attributes, module attributes, wherever you see. The variable they do not have type means Python understands and it instantiates the typing implicitly. Programmer can explicitly declare a variable but not required. Means there are kind of notations through which like if it is double quote then it is a string. Otherwise if it is kind of a decimal number then it is an integer or it is a float. So problem is this. So if I am developing a software or I am kind of maintaining a software, how I should proceed? That is a big task. One work is that I can go ahead and I can just look at the library package if I am developing, or if I am maintaining the current software packages and source code and class code. It's a multi 10,000 lines of code that I need to understand before I start. It takes months. Like any widget programming, if I need to use a widget, then I'll go with the widget class, then search here and there all the derived classes, then think about its kind of usability, means which widget I should use. In Python, adding to a class data structure or adding an attribute to the class instance is runtime. You can add in any methods, in any function. You can kind of grow your class data structure, class instance data structure. Reading code is kind of cumbersome. So what is the solution? Solution is that I should know the design of the library package or design of the current package in advance. If I have the design package, means kind of package diagram or class diagram, interclass diagram, interpackage diagram. So these are called kind of UML schematic diagram or kind of architectural diagram. So rather than going inside the code and picking here and there, it's very nice that if I start my work, rather than investing weeks or months in understanding code here and there, we can have a kind of architecture in the hand. I can take printout of the architecture. I can just browse on my mobile. So if I need a particular class to be used, just I can browse the class diagram, interclass diagram. Inside the class, if I narrow down in few classes, I can just browse through the attributes and its methods, and I can decide, okay, so at this place, this class, I need to instantiate. So class diagram, package diagram, I need to have in my hand. So how I can proceed? I am writing a code, library package or the current software architecture, how I can do it? I have Python source code. Python source code is not a big deal. Means if I install a software in Python, Python source codes are available. I mean, they only execute. Or if software includes a shared library, then Python code means for famous library, anyway it is available on Git Hub, code repository or something. So getting a source code in Python is not a kind of a big issue. So if I have a Python source code, a solution is there any tool or software that would kind of parse the Python code and give me the architecture? I did not go all the places and see that if someone is attached to self or someone is attached to the class data structure or something like that. It's not C++, where the initialization generally happens in the constructor or something. Anywhere kind of attribute initialization or attribute addition can happen. So if I get to have the architecture of the class of the library package or the current package, it is a kind of a boom. Means you can start immediately if you have the blueprint of the architecture. So we'll see the PyReverse tool that parses the Python code and then it generates the kind of architectural blueprint, package diagram, class diagram, inter-class relationship, everything is there. There are few things that is lacking in PyReverse. Like for in a class diagram, we don't have the derived classes, only the kind of parent classes are there. Kind of, we can have our own software that uses the PyReverse, and whatever is lacking, that you can fill in. Just run the tool in 1 hour, 2 hours, full architecture is there. Just use the architecture kind of in PDF format or something. You can just, when you are free, you can just sit and browse the architecture. Start using. So we'll see that how in a reverse engineer we can generate the UML architecture, class diagram, package diagram, and interrelationship through PyReverse and any tool that is using the PyReverse. That way. Further to discussion on the UML reverse engineering through PyReverse tool. So generating the reverse engineering UML diagrams through PyReverse tool. We'll proceed on desktop. This is Linux Mint. So we'll talk about the SkImage. SkImage is another package from in the machine learning area where image processing through the data science is taken care. Okay, so before we proceed on the generating the UML diagram on SkImage, so we'll introduce the PyReverse kind of open source tool. So it is a kind of a reverse engineering tool. It generates UML diagram and package diagram, module diagram, and in the diagram it uses primarily these modeling elements, kind of inheritance or generalization, and aggregation and composition in containment. Okay, so partially whole life relationship and complete whole life relationship. Okay, so dependency or use, association, similar to dependency, but it's a kind of a relationship like dependency. Okay, but not that tightly coupled. Okay, so in the installation of the PyReverse, so PyLint is the package that needs to be installed through either through package manager or through PIP that is kind of Python installer program or preferred installer program. Okay, so through package manager or preferred installer program PIP, it needs to be installed. Then installation of the SkImage. Okay, and then SkImage, once we install, we get the Python code along with it. Python code we can get through Git Hub repository also. Okay, so version of PyReverse and SkImage. So that through dpkg-l we can get the version, or through pip3 list we can also get the version what we have installed. Okay, so PyReverse, the command line arguments means command line options, PyReverse -h, so that we get. So what are the command line argument that we see in the PyReverse? PyReverse module list and package directory. So we need to provide the module list or the package directory itself, which may have sub packages or module. Okay, -a is for all ancestors, -s capital S, capital A, capital S is for all associations. If you want module wise data in the sense complete module path, yes or no. K is for only class skeleton, no attribute and no is methods. If we want information for a particular class, so in this case -k is not required, because if we want complete class information, then -k is not required. So -k is when we don't want -c. Okay, same thing, -a or -a, it is for kind of number of ancestors, so number of inheritance, number of level of inheritance, -s number of level of association. Okay, so complete module wise information, yes or no, or only name. If you want the module name, then no. If you want from the library path beginning ... then yes. Class name, yes or no. Class name, class we want a skeleton, then -k, -k, or if you want full description, then -c and class name. Okay, so Python path need to be set. So Python path is the package directory which contains the package, so that is required. Okay, like this is the sample code we have provided. Like if I have a base package, and base package contains kind of two packages, like in the diagram, base package contains package 1, package 1 contains package 2, and package 2 contains module file. Package 1 contains module file, and the way they kind of look around for the packages here and there, they draws this kind of a diagram, and this is a package diagram, and this is the code everywhere. Like if base init is there, base mod 1 is there, base init package 2 init is there, package 1. Okay, so package 1 mod 1 file is there, package 1 package 2 init file is there, package 1 package 2 mod file is there, and package 1 init file is there. So this is the actual code, and if this code class diagram, it would generate like this if this is the code. So this is a kind of basic architecture, basic drawing what PyReverse would do. Okay, so we'll proceed with the installation of the PyReverse, and then we'll see what it can do, and slowly we'll start doing that. Okay, so we'll create a directory called mkdir PyReverse SkImage. Okay, so there is nothing in the directory, so we'll install sudo apt get install pylint. Okay, so it is already installed. Okay, so we need to install one more package, that is GraphViz, that pylint internally uses, like generation of the PDF file. So that is required for kind of GraphViz we need to install. So sudo apt get install GraphViz. Okay, so it is installed. So these are the version dpkg-l -e pylint. Okay, so these are the versions that is installed. Okay, so I'll try doing man. If man is available, pylint PyReverse. Okay, PyReverse. So these are the these are the kind of command line options for the PyReverse tool. F is the mode. Generally we do all, otherwise we can do some filtering. And -c is if we generate for a particular class, number of ancestor A, capital A all ancestors, -s number of association level, capital S all associations level, -v show the built-ins, -m module complete module path or just module name, -k only class name, only the class skeleton, no attribute and no methods. Okay, what formatting we want, like PDF or whatsoever. Colorized, it will colorize the output. Maximum color depth. Okay, if you don't want few files, project name and where the output would go. Okay, so we'll try to use as many as possible the command line arguments. Now we'll have the installation of the Python 3 SkImage. Sudo apt get Python 3 SkImage. Okay, it is already installed and version is 0.18.3-2. So we'll see where it is. dpkg-l dpkg-l Python 3 SkImage. Okay, so it is in list user lib Python 3 dist packages. So this is the installation directory and this is the package name. So this package name, this directory must be in the Python system, in Python path. So we can set Python path like this, or if it is already available, we can check Python 3 -c import sys print sys.path. Okay, it's available. This is what we are looking. So no need to set that. Okay, so we'll proceed with generating the kind of package diagram. So I'll say PyReverse user lib python 3 dist SkImage. So I can generate kind of a package. So here if I see, so this is the package diagram, this is the class diagram. So these two it generates. Okay, so package diagram will try first. So I need to just provide the path and then a complete formatting we want PDF. It should not stuck. Problem is if we give all association level and all inheritance level, it may kind of hang. So we can just pray that files should not be very big and it should pass through. Okay, it's not very big package. Okay, so result is optimistic. Okay, so looks like at some place it is not passing through. Okay, it's nice. We'll wait for 10 more seconds. Otherwise, we'll try with some sub package because top package looks like it is quite big. Okay, so I'm going to cancel it. So it looks like it is quite big. Nothing is generated. So this is what command we typed. So I'll try with -a, -s1, -my, and we'll try with some directory like viewer -a. Let's try. So this is generating the package diagram, and this is how to generate package diagram. Since SkImage is a package and viewer is a sub package, so it will go for a package diagram. It should pass through because we have given association level as 1. Oh, it's done. We have both classes and packages. I can try packages. Wow. So nice SkImage package diagram it is generating. And we can see that SkImage viewer that is in focus now, and SkImage viewer, it is depend upon viewer.viewers and viewers.qt. That's it. There is no other arrow. Then these are internally depend upon other packages or other modules. But SkImage.viewer is only depend upon these two packages. So nicely it is drawn. We can kind of verify. So I can see user lib python 3 dist package and SkImage, and then we have viewer and then init. Okay, so there are three things. One is it import warn dot shared utils. Okay. Another thing is dot viewers. It imports image viewer and collection viewer, and dot qt. These two has come, and dot qt import has qt. So dot qt this package arrived, and dot viewers this package arrived. Now dot viewers, image viewer and collection viewer, and dot qt has qt. Okay. So image viewer viewer.qt dot is the current directory. So from current directory qt, and viewer.viewers from current directory viewers. That's it. Okay. And now the viewers, it depends upon the core, viewers core. And qt has nothing. So this much it is drawing. So this is the strength of this tool. So the top level package and sub packages, and in the viewers it is core. So we'll see the viewers. Okay, so it is actually dependent upon core. So that's what we see in the, it is as core. So pretty well, means it's okay. It gives good idea. What about the class diagram? Okay, kind of panoramic, means it's good that complete class diagram is there. So full package class diagram is available. Okay, like this much only I can zoom. Like we have wear, canvas tools, rect tools, and rectangle tools. So if I see the directories where what are available in this package, Python 3 dist packages, SkImage. So these are the directories like matrix, measure, registration, restoration, script, segmentation, future, filters. Okay, so right now we are kind of browsing the directory that is the viewer. Okay, so in viewer, these are the classes available, and this is, they are how related. So containment and generalization, so that it is drawing. Okay, so I can have colorized also. Same thing I can try as, we don't have anything now. I'll try same colorized. Okay, so it won't take much time, that we have already seen. Okay. So again we have these many files. We'll see package. What is the situation? This is the situation in colorize. The boxes went away and blue kind of there is no boundary of a rectangle that we are seeing. And if I see the class, okay, it is, I think it is really attractive. So now classes are colored and we can identify colored classes. So coloring would be package wise, sub package wise. This is what I believe. So one color for one sub package and like so. So this is for the widget sub package, matplotlib widgets, and these are for the, I think, canvas some tools base and the array, and this is for matplotlib something. Okay, so not bad one. So class diagram in the colorized format looks good, and for each class attribute and methods are also displayed. So this is what it generates, full package class diagram. Okay, we can go a little deeper and we can generate same thing for the files also. So if I say a user live Python 3 dist package SkImage, and in the viewer section in the canvas tools, this is the module file rect tool. So we can generate for the big package all the package diagram and class diagram. Okay, if we are not satisfied, we can go with sub packages like that, and like at the end we have reached the kind of leaf, that is the rectool.py. In the py we won't get a package diagram because it's a kind of a leaf node. So we'll get class diagram of the rectool. So we'll generate that class diagram. rm star, so there is nothing. Whatever we generated, now we'll go ahead with the canvas tools and rectool py. We'll try with complete because -asmyo colorized. So this would generate for a particular module class diagram. If it takes time, then we will abort and we'll try with the single level association. Okay, so I think we can avoid this as we don't want. So there is nothing in this directory. So we can try with the -a, -m and -my. So association is 1. I believe it should pass through. Okay, it passed through. This is the class diagram for this module. So these are the classes available, and this is the way they are interrelated. I believe it is difficult to understand this much. This is quite big. And if we are curious about the kind of showing the show built-in, show built-in is another option. Okay, I'll try now. So this is with all built-ins, so it is impossible to kind of, it is not usable. Even though we need to know the built-ins, like built-in in the sense like integer, string, dict, list. So if these are the classes used anywhere, then it is not very useful. Another thing is that if we don't use built-ins, then still it is kind of difficult to understand, as every class has attributes and methods, so it's quite big and complex. Still it is big and complex. If someone is happy, then it's very nice. So we can go for just a skeleton. Here every class, like if I am interested in a particular class, not possible. I have to see the methods and attributes of all classes in the diagram. So this is how it generates. If I want only the class or class relationship, I can provide an option called -k. Okay, so it is far better, it is small, and it is colorized also, so one section in one color and another. So this is only the class names and their relationship. This is kind of better in the sense, in a short, in a kind of, in a small diagram, if you want to see a module. So this is the module class diagram. Okay, so this is about the PyReverse. So we entered from the package of a package diagram of a package diagram of a sub package, and then class diagram of a package, class diagram of a module. We can have class diagram of a particular class also. Okay, so this is what we have been trying. So I can say now -a s my -c for a particular class. So in the rectool.py, I want for kind of rectangle tool is a class. I believe so. I think we can grep -e user local lib user lib python 3 dist package SkImage viewer tool rect tool. Okay, rectangle tool is a class. Okay, so this is the only class in this package, so that we can try. So I can say -c rectangle tool colorized. I believe I should use full If it doesn't pass through, then we'll use one level association. Otherwise, complete we'll try. Okay, so I believe that it is too much for this tool. So we'll try with 1 minus S1 minus Y. Okay, so it passes through and it generates rectangle tool.pdf. Wow. So this is the class diagram that we are getting. I don't know where a rectangle tool class is. So this is the what we are looking for. This is the class, and this class derives from this class. So this is a kind of a big diagram. This is how it is. So or we can generate just the skeleton. We'll try with this. Okay, it's accepting. Okay, so same file. Now, just a skeleton we can see. Now it's clear that the class we are looking this class derives from this class and probably derives from this class. So this is what it can, if we generate, so this is the limitation in the tool. Either we can go for a skeleton, then we don't know what is the attribute and property, what is the attribute and method of this class. If we see the attribute and method of this class, then it becomes very big. Everywhere it prints the same way. Okay. Second thing is that there is no derivation of these classes. Which all classes derive from it, that we don't know. Okay. So this is what we get. If we try built-ins, so like if I want show built-ins also. Okay, so if we tried built-in and attribute and methods and everything for one class, this is the diagram. Okay, so these are the limitations in the PyReverse. Someone has to use it in clever way. Okay, so this is about PyReverse. We start from the package, subpackage, module and class diagram. Okay, so whatever the kind of limitation it has, so we have tried to sort it out in a kind of a program we have written that uses PyReverse, and I can copy it here. Okay, so it is PyReverse.py, and this program uses PyReverse. Okay, so it calls PyReverse, and it uses internally it calls PyReverse, and it is called with -f_all. It takes care of the timeout and everything. I mean, I can have like Python 3 PyReverse.py. So this is the command line argument. Now, in Python code, in the SkImage code, there may be Python code available, may not be. So first we try to fix all the Python code available in a package. Once fix is done, then we will start generating the UML diagram. So two steps are there. We can check if Python code is available. Kind of find user lib Python 3 dist SkImage name start.pyx. Okay, there is no Python code here. pxi pyx pxd, nothing is there. Okay, so this tool first settle down all the Python code, and then we can generate the UML diagram class wise. So we can try once, like Python 3 PyReverse.py and fix user lib Python 3. So this is the directory, and this is the package. So we'll just enter. Okay. Okay, so it modifies the file with some information, and it dumps in a directory called SkImage. I can just run this, kind of whatever I wanted, like SkImage and a viewer and okay. So SkImage viewer, in that we are looking for a rectangle tool class. Viewer canvas tools rectools.py. Modify. Okay, so it will try with the full-fledged arguments. If it times out, then it will kind of curtail the arguments. Okay, it times out. It succeeds. So we have now SkImage viewer.pdf. This is what it generates. Now we have this This is a kind of a module file. Inside that we have the class what we want, and these are the methods and attributes, and this is how it is read. It is quite clear that it derives from these two classes and other are containment. So this is very clean diagram, and in many classes it draws the built-ins also. So here there is no built-ins. So this is a clean diagram for a module, and for a class also it generates. So I can try for the class. Okay, so we'll remove PDF and dot file. Okay, so with the new tool, the idea is that it should draw okay, so it should draw the kind of a package diagram for a package, and it would highlight a class. So we'll say Python, and this is the tool, and we'll say modify sklearn SkImage viewer. So this directory will make, and will give the complete path of the class what we want. Canvas tools dot rect tool dot rectangle tool. Okay, so we'll give timeout as kind of 120 seconds, 2 minutes, and association level to 1, and we'll say ignore tests. So tests we don't want. Okay, so it is processing this file. It should not take much time, as association level is only 1. So probably in a minute it should return. Okay, so it returned. Now I can do SkImage viewer canvas, and this is the package diagram of the viewer. Let's create the the default. So this is what we received now, and what would be the default generated by the Python PyReverse code. So PyReverse code would be like this, the package diagram. Okay, there also we can ignore tests. Okay, and this would be minus a minus s1 minus my, and output would be PDF. So this is what would generate class.pdf. I think I have given correct, minus a minus s1 minus my, and then ignore test and minus opdf. It would take similar kind of time. Okay, nice. Now we have classes, so I can say classes. Okay, so this is what package diagram for the class is being generated. I think it is difficult to pinpoint where is the rectangle tool if I want for rectangle tool. This is good for if all the classes we want, and this is what the new tool has generated. So rectangle tool is highlighted by red, and then so nicely it generates the full package dependency relationship from the rectangle tool onwards. So this is package class diagram for a package. This is class diagram for a package generated through the default tool. So it has property and methods, but for all the classes. Okay. So if I want only a skeleton, then I have to specify. I think I have shown. So the new tool. So the new tool is doing the magic. So for each class, for package we can generate, for each class we can generate, for each Python file we can generate. So we'll see that how it would be for each class. So I am going to remove all the PDF and all the dots. There is nothing. So I'll say Python 3 PyReverse. This is our file. Modify SkImage viewer. So everything just clean up in this directory, and nothing need to be changed. I can just say ignore test. That's it. So this is quite simple, and timeout and everything it will be taken care. So all the classes inside SkImage viewer would come now. So there are 32 classes. For each classes, it would generate kind of reverse engineering UML diagram. Probably it would take around 10 minutes. Okay, so it is getting over, and we'll get a UML diagram for all 33 classes. Okay, so it's a big list, and so this is the class diagram for each classes. The good thing is that we don't miss the derived classes. So in the kind of original tool, we miss the derived classes. Here derived class is available. All skeleton is available. And for a particular class, we have the attribute and methods. So that we get in the new tool. Okay, so likewise we can see others also. Kind of okay, so this is the other classes. There is it generates an output directory it generates a complete PDF. So all 32 classes PDF we can see, like we have the class called Canvas tool base, and these are the derived classes from it, like this. So panoramic, all the classes, rectangle tool class, nothing is derived from the rectangle tool as okay. Plugins base, so this is the derived class. So like this, for all classes we get in one PDF, all 32 classes. So this tool clearly generates so this tool, as we described, the fix and modify. So for all the classes in a package or in a module file, it generates. So we can what we did is we generated for sub package. Okay, so generated for viewer, we can go for full SkImage. So now I am generating full UML diagram for SkImage, ignoring the tests. Simple, modify SkImage, that's it. Okay, so there are 45 remaining, 32 anyway we have already made. So 45 remaining, it would execute. It will take some time. Now in the it is generating the per class UML diagram, and everything would be available in output directory in the PyReverse file. Okay, once it get complete. So we covered kind of introduction to installation, and GIT hub we can clone from here, and then we can do the fixing, and same story, and generating the package and module. I think one more file is remaining. So we are here. So many files it has generated per class files. I believe one more is remaining. So this is the last one. So the way we saw that we have group of class files. Okay, so it is done. Now it is kind of generating the PDF file and attaching the PDF file to one PDF file. So it has done for all 77, I believe, 77. So it is complete. Now I can just see output. So I can say PyReverse. Okay, so this is a big file. and it has everything. Okay, there is one yellow line for all the associations. If association count is too many, like 4 we have, rather than just showing, so these are the modifications in this tool. So yellow line is for, yellow box is for if association is more, then rather than showing a big diagram, it can be clubbed together. Okay, so that is the idea. And green line is for derived classes. Okay, it can be seen in threading conditions. Threading conditions contains thread rlog, collections dq, and threading rlog. So we don't want that big diagram unnecessarily. So this is how it is. Oh, this is derivation. So one class is derived from. So it's a kind of a complete diagram. In a class diagram itself, we get complete diagram, derivation plus this class full feature, then its inheritance, everything. These are independent classes. So nicely drawn. Everything, all information, nothing is missing. Okay, so rect tool is the big one. Now we have plot plugin and two subclasses are there, and plot plugin derived from the base plugin, and it has two containment that is shown clearly. Okay, so we are at the end. I can search for any class. So I can search for kind of rect tool dot rectangle tool. Nothing. Rect tool dot rectangle. Wow. So we can search for a particular class and we can see. Okay, so we saw the both the PyReverse that comes with the PyLint package and a kind of a utility that is written on top of PyReverse that generate a per class diagram, package diagram, everything, and kind of it is more neat, more informative. That also can be done. Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.